With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question is, extremely pure samples of germanium and silicon are non-conductors, but their conductivity increases suddenly on introducing dash in the crystal. The options are arsenic, boron, both 1 and 2, or none of these. Now here the concept that we are going to use is the concept of doping. Right. So what happens is that when an impurity, right, when a small amount of impurity is added, right? Some very small amount of foreign impurity or impurity is added to the host crystal, right? Is added to the host crystal. This is what doping is, right? And if we talk about this process of doping, this increases the electrical conductivity in the crystal, right? This increases the electrical conductivity in the crystal, okay? So initially you have pure samples of germanium and silicon, right? So whenever we are going to dope it, it is going to increase the electrical conductivity. When we are going to add small amount of impurity in it, it is going to increase the electrical conductivity, right? Now, if we talk about germanium and silicon, then germanium and silicon both are group 14 elements, right? Both are group 14 elements. Now, when a group 14 element is doped with, an impurity of group 13, right? So group 13 impurity, which is boron, right? So whenever a group 14 element is doped with a group 13 impurity like boron, what happens? It leads to the formation of a p-type semiconductor, right? It leads to the formation of a p-type semiconductor, right? Because when we are doping the group 14 element with a group 13 element like boron, what is happening? What is happening is that it is going to produce holes, right? This has a deficiency of electrons, right? It has a deficiency of electrons. So it is going to produce holes, right? This is going to produce holes. And as electron deficiency is created, holes are created. This represents the flow of positive charge, right? And therefore, these type of semiconductors are known as the p-type semiconductors, right? Now, when a group 14 element is doped with a group 15 impurity, right? Group 15 impurity like arsenic, then what happens? There's an excess flow of electrons, right? There's an excess of electrons, and this leads to the formation of a N-type semiconductor, right? So in the case of p-type semiconductor, more holes are created, and in the case of group, when it is doped with group 15, and in the case of N-type semiconductor, more electrons are there. So in both the cases, the conduction is going to increase, right? Because of the increase in the positive or the negative charges. So in both the cases, so in general, whenever an element of a group 14 is doped, whether a group 13 impurity, whether a group 15 impurity, the conductivity is always going to increase. So the correct answer for this question is going to be both 1 and 2, right? That's all for the question.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.